This is problem number 8-91. Use the pattern from the previous problem to help you evaluate the following expressions. So we're dealing with imaginary numbers and we're simplifying them. And all of these exponents are really large, but the answers are actually going to always be only I, which is I to the first, I squared, which is worth -1, I cubed, which is worth -I, or I to the fourth, which is worth +1. Those are the possible answers that we're going to end up having. I, -1, -I, and +1. So it's not really going to be this. So just like you simplify exponents with, like x squared times x to the third, you actually combine those together and make it simpler, and it reduces there. We're going to do the same kind of thing here and only get one of these 4 answers. So let's look at part A, which is I to the 592. So this pattern repeats every 4 times. If you go to I to the 5th, it'll get you back here. I to the 6th is really simplified to this. I to the 7th is this. I to the 8th is this. So the pattern's repeating every 4 times. So if I take 592 and divide it by 4, this is saying how many times is this pattern happening. So I get 148 there. So what that really means is I have I to the 4th 148 times, okay? Because you multiply these exponents together, and that would have given you this. But I to the 4th is really worth 1. So I have 1 to this 148th power. Oops, there we go. Which is really just 1. Okay, so we can simplify to that. So we're seeing how many times does this pattern repeat. This one there was no remainder needed. So let's look at B and see if that happens again. I to the 797. So again, I'm going to take 797 divided by 4 because that's how much my pattern repeats. And I get 199.25. So what that means is I have I to the 4th 199 times. If I were to multiply those together, I get 796. So I need one more. I need one more because this multiplies to be 796, and this is, you really add this exponent here, so you get 797. Okay, so this itself was worth 1, just like it was up here, and now it's times I. So I just get my final answer is I. So let's see, this part right here is worth 1. Okay, the I to the 4th is just worth 1 raised to whatever power, doesn't matter. So that's always going to be 1, and then this end part left over is what we kind of care about. That's what it's going to simplify to. So then C, we have I to the 10,648,202. Okay, so again, we're going to divide that 10 million number by 4. 648,202 divided by 4. Again, we're doing 4 because this pattern repeats after 4 times. All right, so we get a 2, let me write this down here. I to the 4th, 2662050. That's whole times, okay? But I have a 0.5 left over, so that means I didn't get to this number. So I'm going to take and multiply these two together and see what we're missing still. So 4 times 2662050. That gets me to blah, 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 200. And I need to get to 202. So I need another 2 more up here. All right, remember when it's like this, you add the exponents when it's got this multiplication. When they're in parentheses up here, you multiply them together. So now this plus the 2 would get me to the original exponent I needed. And then something I to the 4th to the whatever that's just worth 1. I have 2 million of these I to the 4th multiplied together, which is still 1, so it doesn't really matter. So this is what we care about. So really, per part C, it's going to be simplified down to I squared, but we know that's really the same as -1. Okay, so if you can get i's out of your answer, you should do that. Otherwise, it's okay to have one of these first 4 things as your solution.